In 2019, astronomers pointed their telescopes at a region 700 million light-years away and found something that shouldn't exist. A void, an enormous empty nothing. So vast, so perfectly empty, it breaks our understanding of physics. But this isn't the only anomaly. Across the observable universe, we're finding structures too big to have formed. Signals with no explanation. Regions that seem to defy the laws of physics entirely. And the deeper we look, the more we realize something uncomfortable. Either our understanding of the universe is fundamentally wrong, or something out there is very different from what we expected. Today, the most baffling anomalies in deep space. Discoveries that keep physicists up at night. Things so strange they might force us to rewrite everything we thought we knew about reality. So, let's dive in. The cold spot. Now, in 2004, scientists were analysing the oldest light in existence, the cosmic microwave background, the afterglow of the Big Bang itself. This radiation fills all of space at roughly the same temperature, 2.7 degrees above absolute zero, almost perfectly uniform. Almost. In the constellation Eridanus, they found a region noticeably colder than everything else. 70 microkelvin colder, spanning 1.8 billion light-years. Now, in cosmology, that's enormous. The odds of this forming naturally, about 1 in 200. Scientists proposed an explanation. A super void. A vast region with very few galaxies sitting between us and that section of the CMB. The supervoid only accounts for about 10% of the temperature drop. Something else is causing this. And some physicists have gone further. One proposal? The cold spot might be a cosmic bruise, evidence of another universe pressing against our own. Is that likely? Probably not. But the fact we're even considering multiverse theory tells you how stumped scientists really are. And the cold spot is just the beginning. Because something is pulling us across the universe right now, and we still don't know what it is. So our Milky Way, along with thousands of nearby galaxies, is moving. Not just expanding with the universe, being pulled in a specific direction at 600 kilometers per second, over 2 million kilometers per hour toward a single point in space. The problem? We can't see what's there. The Great Attractor sits in the zone of avoidance, a region blocked by our own galaxy's gas and dust. And for decades, this was one of astronomy's greatest mysteries. Now eventually, infrared and X-ray telescopes pierced through, and they found massive galaxy clusters. Norma, Centaurus, and behind those, the shapely supercluster, one of the most massive concentrations of matter in the observable universe. Mystery solved? Well, not quite. Recent studies show the gravitational dynamics are more complex than expected. There may be additional unseen mass, dark matter structures we haven't detected, contributing to this cosmic pull. We're being dragged across the universe by something we don't fully understand. And there's nothing we can do. We're just along for the ride. But if that's unsettling, wait until you see what we found in 2021. A structure so massive, it shouldn't be possible. Graduate student Alexia Lopez discovered something that sent shockwaves through astrophysics. The giant arc, a crescent of galaxies, clusters and gas spanning 3.3 billion light-years. years, 1/15 the size of the entire observable universe, a single coherent structure. Here's the problem. Cosmology rests on the cosmological principle. On large scales, the universe looks the same everywhere, and this means structures should max out around 1.2 billion light-years. The giant arc is nearly 3 times that limit. And it's not alone. The Hercules Corona Borealis Great Wall stretches 10 billion light-years. The huge large quasar group spans 4 billion. We keep finding structures that shouldn't exist. Now, some argue these are observational artifacts, patterns our brains impose on randomness. But statistical analysis puts the odds of coincidence below 0.01%. If these megastructures are real, either our models of cosmic evolution are missing something critical, or the universe had far longer to form than 13.8 billion years allows. Either way, something's wrong. And it gets stranger, because the universe seems to have a preferred direction, and it points directly at us. The axis of evil, not politics, cosmology, and possibly more disturbing. The cosmic microwave background should be random. Quantum noise from the Big Bang, pointing in no particular direction. But the fluctuations align. There's a preferred axis along which primordial radiation patterns organize themselves. And here's the creepy part. This axis aligns with our solar system's orbital plane around the galaxy, and with the plane of the solar system itself. It seems to point right at us. The cosmological principle says we're not special. Ordinary planet, ordinary star, ordinary galaxy, ordinary location. But the axis of evil suggests otherwise. Most likely explanation? Systematic measurement error, local interference contaminating the data. But WMAP found it, Planck confirmed it, different satellites, different methods, and it won't go away. Some researchers propose the universe has a slight rotation, or even that space itself is anisotropic on the largest scales. Or, and this gets a little philosophical, maybe we really are in a special place. The axis of evil remains one of cosmology's most unsettling anomalies, but here's what's currently tearing physics apart. 2 measurements of the same thing that refuse to agree. The Hubble tension might fundamentally change everything we know. The Hubble constant tells us how fast the universe expands. 2 ways to measure it. Method 1. Study the ancient cosmic microwave background. Calculate what expansion should be today. Result: 67.4 kilometers per second per megaparsec. Method 2. Measure nearby galaxies using Cepheid stars and supernovae. Result: 73 kilometers per second per megaparsec. Now, these numbers don't match, and the discrepancy is far beyond measurement error. Scientists assumed someone made a mistake, but measurements got more precise, error bars shrank, and the gap only grew more significant. The odds of this being random chance? 1 in a million. Something is wrong. Either there's a systematic error nobody can find, or our understanding of the universe is incomplete. Proposed solutions require new physics, dark energy that changes over time, early dark energy bursts after the Big Bang, undiscovered particles called dark radiation. The Hubble tension isn't academic curiosity. It's a crack in cosmology's foundation, and it keeps getting wider. But perhaps nothing is more mysterious than what's been arriving from deep space since 2007. Signals we're only beginning to understand. Fast radio bursts, milliseconds long, releasing as much energy as the sun produces in a day. When astronomers first found them in 2007, they assumed interference. microwave ovens, satellites, something mundane. Then they found more, from every direction, from billions of light years away. And in 2020, one came from inside our galaxy, traced to a magnetar, a neutron star with insanely powerful magnetic fields. Finally, a source. But new questions emerged. Not all FRBs match magnetar behavior. Some repeat in patterns. One cycles every 16 days like clockwork. Some patterns seem almost structured. Scientific consensus? Natural explanations. Magnetars, neutron star collisions, exotic phenomena we're still learning about. But unexplained signals from deep space, repeating in mathematical patterns, releasing extraordinary energy? Well, you understand why some researchers haven't ruled out other possibilities. FRBs remind us how much remains unexplained, how many mysteries wait in the darkness between stars. So, voids that shouldn't exist, structures too vast to form, an expansion rate contradicting itself, signals we're only beginning to decode. Each anomaly reminds us our knowledge is incomplete. The universe owes us no explanations. It's far stranger than we imagined. Maybe we'll solve these puzzles. Maybe new telescopes and theories will illuminate what seems impossible. Or maybe we'll find something stranger still. The universe keeps surprising us, and honestly, I wouldn't have it any other way. So which anomaly disturbed you the most? Drop it in the comments, subscribe if you want more cosmic mysteries, and we'll see you in the next one.